Bismillahirrahmanirrahim. Today I thought I would do some a little bit more challenging, perhaps more intellectually stimulating quadratic equation problems. I hope you enjoy them. So here's the first one. For which values of b, so we asked to basically solve for b, for which values of b will the quadratic function, which is given here, will the quadratic function f of x equals x squared minus 2bx plus 7 have a minimum value of 6? Okay, so we're asked to find the value of b. Okay, they could have used some other variable here, k or p or m, whatever. For which value of b will this function? Now, we're not given the whole function, see? We're not given like f of x equals x squared minus 5x plus 13, right? We're not given this. We're given this in like a mystery fashion, right? So we're given this to minus 2b. In other words, for which value of this will this function have a minimum value? Okay? So the first thing, of course, you have to know what a minimum value is. The minimum value occurs for a quadratic function, a parabola, when it looks like a u, and the parabola looks like an n, it will have a maximum value. The minimum value of a parabola is the f of x corresponding to the vertex. In other words, if the vertex is vx and vy, or x and f of x of that area, the y here is the minimum value, vy. Okay, that's the minimum value of the function. That's the definition of a minimum value. So if you don't know that, then it's going to have a hard time solving this equation, right? Solving this problem. So for which value of b will we have a minimum value of 6? Okay. Well, how do we go finding out what this is? Well, how do we ordinarily find the minimum value? The way we find the minimum value ordinarily is we find the vertex, the x component of the vertex, we find vx, then we use to find vy, and vy is going to be the minimum value. Now, vy being, of course, the y coordinate of the vertex, right? Okay. How do we find vx? This is in the standard form. Vx, as we know, is opposite of b over 2a. Now, this is not the same b. They're making this trickier by saying that this is a b. This could have been k and it'd be less confusing. The way we find the vertex is taking opposite of b, and this being this, f of x equals ax squared plus bx plus c. Now that's this b. Okay, the coefficient of the term, the middle term of this function. So that's how we find the vx. Okay, let's find the vx over here, the x component of the vertex. That's going to be opposite of b. In this case, b is this, minus 2b over 2a. In this case, that's 1. So the x component is, this is just 2b over 2, or b. For this component, vx is b. Okay, then how do we find vy? Well, we substitute that in the function, right? So vy, the y coordinate of the function, will be basically f of b. That would be b squared minus 2 times b times b. This is the substituted b, plus 7. Okay, plus 7. And you want the vy to be equal to 6. Okay, that's what you want. Okay, so we can simplify this. This is b squared minus 2b squared plus 7 equals to 6. Okay, so this is the equation we need to solve, okay, in order to find this. So this is negative b squared plus 7 equals to 6. Okay, then you get negative b squared equals minus 1. And then you multiply by negative 1, you get b is equal to plus or minus 1. So when b is plus 1 or minus 1, it will give you the minimum value of this function to be 6. Okay? So that's this first problem. I hope you got that. I hope you're not intimidated. and haven't scared you. But for which value b will the quadratic function have a minimum value of this? Well, how do we find minimum value? First we find the x coordinate, and then from there we find the vy, which is the minimum value. So in this case, opposite of b over 2a was opposite of this over 2a. That was this, so the x coordinate is that. And we substitute that in the original function. We got this, and we want that to be 6 because that's what we want. And we solve that, and for b, you get plus or minus 1. So whenever b is plus or minus 1, we will get this function to be minimum value of this. Now, so let me share this with you. Y equals x squared minus 2x plus 7. Okay. Okay, now this, in this case, b is 1, see? Now when b is 1, okay, the minimum value is 6. Okay? Now when b is negative 1, if I put a negative 1 there, the b is also 6. Okay? Let me draw this as a separate graph, okay? So y equals x squared minus 2 times negative 1 times x plus 7. So now these are two graphs whose both quadratic functions whose both minimum values are 6. And that is how we got this answer here. Okay? So when b is plus or minus 1, we'll get the minimum value to be 6. That's the first question that we have. Okay. All right, so I'm going to move this ping pong up here. Let's get this. All right, let's try this one. The length of a ping pong table, like that, thought you'd like that. The length of a ping pong table is, so the length is 3 more than twice the width. The area of the ping pong table is 90 square feet. What are the dimensions of the ping pong table? Well, to do this, okay, let's draw out our ping pong table here. Okay. Okay, so the length of a ping pong table is 3 more than twice the width. So the width is W. The length is going to be 3 more than twice the width, like this. Okay. And the area, we're told, is 90 square feet. Okay, so the area of this ping pong table is 90. Okay, now how do we calculate? That's length times width, right? So 90 is going to be 2w plus 3 times w. Okay, now you distribute this, you get 2w squared plus 3w. Okay, now we have a quadratic equation, see? So I'm going to bring like this, 2w squared plus 3w minus 90 equals to 0. Now, in the interest of time, right, I'm going to kind of do the math here a little bit. To solve this, you can do whichever way. I'll just use the quadratic equation, opposite of b plus or minus square root of b squared minus 4 times a times c over 2a. Okay, when you do this, you get negative 3 plus or minus the square root of this whole thing turns out to be 27 over 4. Okay, and when you get this, you get two answers. The width is going to equal, this is w. The width is going to equal to negative 15 over 2, and that can't be because the width can't be negative. It's not a practical answer. The width is end up to be 6, so this is going to be the answer. So the width is going to be the 6. The length is going to be 2 times 6 plus 3. That's 12 plus 3, and that is 15. So the dimensions are 6 and 15. Okay, so that's easy enough, right? Hopefully. Now here's an interesting question, okay? I think I have 6 questions just to kind of give you an idea. 5 or 6. Two rectangular corrals are to be made from 100 yards of fencing is shown below. So somebody's making these two rectangular corrals. I don't know what they're going to put in there, but they're going to put in there. So, and they have 100 yards of fencing, okay? If the rancher wants the total area to be maximum, what dimensions should be used to make the corral? Now, this is a very interesting question because from a certain given amount of fencing, you can make different types of corrals. You can, for example, you can do one of these, okay, with the same amount of fencing, or you can do one over here, but the area will be different, okay? So, how are we going to do this? Okay, let me just get rid of this extra stuff over here. Okay, so let's see what we can do. First of all, we don't know what the width is going to be. We don't know what the length is going to be, right? That's what we're trying to find, okay? So let's just call the length to be L. Okay, if this length is L, it's a rectangle, so all of these are going to be L. Now remember, this has to be taken into account too, because it's a fence, right? Right? It's not going to be just these two, okay? There has to be a fence also in between. The other house are going to make two. So that's fence, fence, fence. Okay. And the width is going to be, the whole width is going to be W. Okay. And this whole thing is also going to be W, right? Now, if you take this length over here, it doesn't matter if you put it here or if you put it over here, right? Because this included area is going to be the same. So where this middle fence is going to be is not as important because the total area is still going to be the same. What's going to be critically important with the width and the length is, okay? So what do we know? All right, we know that this is how much fencing that we had. That means all of the fencing must have to add up to that. Well, what is that? So 100 is going to have to add up to 3 L's, okay, plus the 2 widths. So that's basically the whole length and the width, right? Okay. And then we want the total area to be maximized. Okay, how do we calculate the area of this corral? That's easy. Now that's length times the width. Length times the width. Okay, so we got that. So we actually made pretty good progress here, okay? Now what do we do? Okay, we want the area to be maximized, okay? Well, what I'm going to do is, I'm going to have to get rid of one of these here, I think. Okay, so I'm going to solve this one for, I'm going to solve that one for width. Why? I don't know. I know why, I know, but the reason is because 100 divided by 2 and 3 doesn't divide 100. I know, that's why. But I'm going to solve this for W. So W is going to equal to, I'm going to 100 minus 3L over 2. Okay, I solved that for W. And then I want to substitute that over here. Okay, that's going to be L times 100 minus 3L over 2. Okay, like this. All right. So, and then, well, I'm going to distribute here. I'm going to get, I'm going to separate this out, okay? So let me just do it slowly. That's going to be 50 minus 3 over 2L. Okay, I did that. I separated these two out. And then I'm going to distribute. I get 50L minus 3 over 2L squared. Now this is the formula for the area. Now look at this formula for the area of the rectangles. I'm going to write it like this. 3 over 2L squared plus 50L. Okay, that's the area. Okay. Now we want this area to be maximized. Now, what first thing is you have to understand what this is saying. This is not an equation. This is a function. Okay. Now what it is telling you is the area that you're going to result depending on what length you choose. Okay. And if you look at this function, it's a quadratic function. That's with a negative a. So I'm just going to draw some random quadratic function. It's going to be n like this. Okay, and on this axis, in color, okay, you're pretty good at in color here. On this axis, the x-axis is the length. For any given length, okay, for any given length over here, you'll get the area. Area is on the y-axis, okay? If I choose this length, I'll get that area. If I choose this length, I'll get that area. If I choose that length, I'll get that. If I choose this length, I'll get that area, okay? But I want the area to be maximized, so I want this length right here. That's going to be the vertex, okay? So if I find the Vx, the L for the Vx, that'll give me the maximum area, right? So this is a function that gives you the area based on the length. Now, if I had solved for L and substituted this for L, I would have had an area based on the width. Either way, I would get the right answer, okay? So I just have to find the Vx, because the Vx will give me the length for the maximum area. Okay, so let's find the Vx. So Vx is opposite of b over 2a. We know what b is. B is this. So negative 50 over 2 times a. Well, a is negative 3 over 2. Oh, that's pretty convenient. Okay. So I'm going to get my ink back here to red. Okay. So that's gone. I didn't get back ink to red. In color. Okay. Okay, that looks better. So those two are gone. So this is going to be negative 50 over negative 3, or 50 over 3. That's the length. This length will give me the maximum area because that's Vx, and that'll give me the maximum area. Now that I have the length, I can find the width. Okay, the width is going to be 100 from here minus 3 times the length, which is 50 over 3, whole thing divided by 2. That's 100 minus, that's gone. That's 50 over 2. That's 50 divided by 2, that's 25. Okay? So, 50, that's 25. Okay? So, if I do it like this, then I will get the maximum length and the width. Okay? Now, this width is the whole thing over here. And length here is one of these lengths over here like that. Okay, and that's the answer to this question. Okay, this one is not too bad, I think, inshallah. The product of two consecutive integers is 99. Find the integers. Well, if the first integer is x, this is two consecutive odd integers. The second odd integer would be x plus 2, right? If x is an integer, the next integer is x plus 1, the following integer is x plus 2, the following integer is x plus 3. If x is an integer, the next odd integer is this. If x is an integer, the next even integer is x even integer. The next even integer is x plus 2, like that. We have done that before, so I hope that that's reasonably familiar. So if we have two consecutive odd integers like this, two consecutive odd integers like this, okay? The product of two consecutive odd integers, the product of two consecutive odd integers is 99. Find the integers. Okay, that sounds good. So that's x squared plus 2x equals 99. X squared plus 2x minus 99 equals 0. I think I can factor this. X, 99, 11, and 9, 99. Different, bigger one is positive, negative equals 0. So x is equal to negative 11, or x is equal to negative 9. Positive 9. If you solve this, right? So if x is the first integer, if the first integer is negative 11, the second integer is going to be negative 9, x plus 2. If the first integer is 9, the second integer is going to be 11. The product of both of these, as you see, is going to be 99. Okay? Got that one? Sure. All right. Now I think this is the last question we have. The ages of three family children can be expressed as consecutive integers. Okay? First child, second child, third child. Okay, their ages can be expressed as 3 consecutive integers. Okay. The square of the age of the youngest child is 4 more than 8 times the age of the oldest child. Oh, okay. Find the ages of the 3 children. All right. Let's do it again. The ages of 3 family children can be expressed as consecutive integers. So the first one is x. The second one is x plus 1, consecutive integer, not consecutive odd or anything. And the following child will be x plus 2, they're consecutive integers. Okay, we got that. The square of the age of the youngest child, the square of the age, so square of the age of the youngest child is equals to 4 more than 8 times the age of the oldest child. 8 times the age of the oldest child plus 4. All right, that's it. The square of the age of the youngest child is 4 more than 8 times the age of the oldest child. That looks pretty good. Find the age of the children. Okay, let's do it. Solve it. X squared equals 8x plus 16 plus 4. Distribute. I'm going to bring everything to this side. X squared minus 8x. This is 20 minus 20 equals 0. 20. Bring it on this side. Now I think I can factor this. X and X. 20, 2 and 10. Different. Bigger one is negative and positive, like this. Okay, I think that is correct. So from this I get x equals negative 2. That doesn't make any sense because the child can't be negative 2 years old. And from this I get x is equal to 10. So the first child is 10 years old. If x is 10, the next child will be 11, and the next child will be 12. So those are the ages of the 3 children in this family. All right. I think those are the questions that we have for today. I hope you enjoyed those. Until next time. Assalamu alaikum.